the director of CSIR, Crop Research Institute, and I wish my staff Merry Christmas and a prosperous New Year.
Welcome to the CSIR Crops Research Institute, one of the 13 institutions of the Council for Scientific and Industrial Research. It is the leading agricultural research institute in Ghana, established in 1964. Our mission is to develop and disseminate demand-driven technologies and build capacity for sustainable food and industrial crop productivity to enhance livelihoods. Our vision is to become a center of excellence for agricultural research, innovation, and capacity building for development. Yam is a very important staple tuber crop in Ghana. It is a ceremonial and export crop. Traditionally, the crop propagation is vegetative using the edible tuber. The foremost constraint of yam production in Ghana is unavailability of quality seed yam. Typically, the seed system is informal, where farmers' saved seed is used for planting, and these harbor a lot of diseases and hence lower their yield and profit margin in yam production. The Yam Improvement for Income and Food Security in West Africa Phase 2 project, that is YIPSWA 2 project, seeks to develop a formal and functional seed yam system to benefit smallholder farmers through the timely and affordable access to high-quality seed yam tubers of improved varieties. The project is hosted in the International Institute for Tropical Agriculture, IITA, Nigeria, and providing technical and financial advisory services to smallholder farmers in Ghana and Nigeria. This project is being implemented in Nigeria and Ghana, where we are obtaining improved crop varieties of yam and cleaning them through tissue culture techniques and applying innovative high-ratio propagation techniques like tissue culture, aeroponics, hydroponics, temporary immersion bioreactor system to ensure the availability of quality yam seedlings for field establishment. In connection with this, the YIPSWA project is aiming at building the capacity of the demand-driven production system in an enabling environment for improved varieties of seed yam with 4 main objectives. The first objective is to empower smallholder yam producers with the seed of improved varieties for increased productivity, which will result in increased income. The second objective is to develop a functional and sustainable seed yam system, which will deliver sufficient quantities of high-quality seed yam of improved varieties to farmers at the right time at affordable prices for adoption. Thirdly, the project is looking at raising awareness of economic impact of the seed yam in the yam sector. And this, we are looking at prioritizing national and regional as well as international programs to engage in the seed yam sector. The fourth objective of this project is to empower women to profitably participate in the commercial production of seed yam in the seed yam value chain with the context of their socio-cultural involvement in the seed yam system. The Tissue Culture Laboratory is that aspect of our activities where the plant material is obtained from the farmer's field and as well as the breeder field to be introduced into the system for cleaning and the various high ratio propagation techniques.
To develop clean stock of nuclear seeds, it is important that breeder seeds are cleaned using in vitro techniques. Farmer-preferred varieties are also cleaned, and because they harbor a lot of disease pathogens, it is important that they are cleaned from viruses, bacteria, and fungi. Our laboratory ensures and maintains the genetic integrity of the seeds that we produce, and hence products are true to type. In the tissue culture lab, the nodes of the mother plant are cut and the shoot tip meristems are excised using the microscope and put on nutrient medium in the laboratory. Shoot growth is normally obtained within 8 weeks, at which cultures are sent to the molecular laboratory of the Biotechnology Center for Nucleic Acid Extraction and Virus Indexing. Cultures which are certified as clean from viruses based on the molecular diagnostics are subjected to the high ratio propagation methods using conventional plant tissue culture and temporary immersion bioreactor systems. Here we use two types of temporary immersion bioreactor systems.
I'm the director of CSIR, Crop Research Institute, and I wish my staff Merry Christmas and a prosperous New Year.
That is the Rita system in the plant form. The nutrient solutions are in a different part of the vessel and they are pushed by these pumps against gravity to feed the plantlets in a timed manner. In 6 weeks, we can generate 8 plantlets from one single plantlet, and this is the high ratio propagation technique that we are talking about. Afterwards, we take them through the shoot development process where we use hormone-free medium. Completely developed plantlets are then subjected to start the weaning process in the greenhouse. According to the indexing results, cultures that are not clean are then taken through thermotherapy or heat treatment at a temperature of 36 degrees in the day and 32 degrees in the night for 30 days. Afterwards, the shoot tip meristem is excised and grown on appropriate medium. The meristem is an actively growing part of the plant where diseases cannot stay. Usually, after this stage, 95% of the samples come out as clean. Prior to exposing the tissue culture, and after 6 weeks, they are ready for the greenhouse.
The molecular laboratory is the aspect of our activities where the materials that have been subjected to tissue culture are tested to certify that they are clean prior to high ratio propagation.
The laboratory technologist is sampling some leaf tissues from the greenhouse, which will be used to test for the presence of viruses in the nucleoside and the single-node seedlings. She is extracting RNA from the leaves. Here, we have the RNA, which is being used to conduct a test to see if the leaf tissues she took from the greenhouse are clean or are infected with the viruses. Those identified as clean will be advanced to the aeroponic system for seed yam production. Those that are infected with the viruses will have to go through the heat therapy process to get rid of the viruses. These will be tested again in the laboratory to confirm if they are clean. This is a quality assurance system that assures that clean, healthy and high quality seed yams are distributed to farmers.
In the screen house, we have the aeroponic system where the seed yam, which have been cleaned from tissue culture, are grown in the system where the roots are fed with nutrient solution for the high ratio propagation of the plants to establish them for seedling propagation. Alongside the aeroponic system is the hydroponic system, where also the plantlets developed from tissue culture are fed with nutrient solution for vegetative propagation. We harvest the single nodes from the aeroponics and hydroponics to produce seed yam seedlings for field establishment.
In the screen house, tissue culture yam plantlets are received and hardened in a humidity chamber to mimic the environmental conditions in the growth room. After 4 to 6 weeks, the hardened or weaned plantlets are transplanted either onto a hydroponic system or an aeroponic system, which are high-ratio propagation technologies. Aeroponics is the process of growing plants in the air or in a misted environment without the use of soil or an aggregate medium. At the CSIR CRI Aeroponics facility, planting material for seed yam seedling production are generated in the form of single-node vine cuttings and mini tubers from the aeroponic system. As many as 100 single nodes can be harvested from one plant in the aeroponic system to generate seedlings. The single-node vine cuttings from plants growing on aeroponics are harvested and nursed in the screen house in plastic bags. The seedlings are then transplanted onto the field when fully hardened. The nutrient solution is powered from a pumping system in the powerhouse, which serves as a source of nutrition for the yam plants. The hydroponic system is also a means of generating seed yam seedlings from the yam vines that are growing in the screen house. In Ghana, farmers face the challenge of obtaining clean quality planting materials at their desired time. However, with these systems, the challenges are remedied and thousands of planting materials can be generated for the farmers to grow several hectares at a time.
On the field, we have the establishment of seedlings generated from single nodes for clean seed yam production. Following this, we also plant foundation seed 1, foundation seed 2, and ware yam, demonstrating the effectiveness of the aeroponic, hydroponic, clean seed yam systems.
Single nodes that are deemed cleaned from tissue culture is sent onto the field. Initially, they are acclimatized before they are sent onto ridges already prepared on the field. Single nodes are planted at a distance between 20 to 30 centimeters on the ridges. After 2 weeks, they are helped with the help of a string to help it climb to ensure that leaves are exposed for photosynthesis, which will help to increase yield of yam. We harvest them between 4 to 6 months, and you could see yield from single nodes. Yield under the single node performance ranges between 500 grams to 1 kg. This forms part of the first generation of yam production. Under the mini set technique, seed yam is cut into pieces, which has an average weight of 20 to 25 grams. The mini sets too are planted on the ridges between 25 to 30 centimeters on the ridge. Tubers.
These tubers are classified as foundation ones planted, generate certified seed yam tubers. Under ware yam production, these are planted in mounds and is managed on the field for 8 months for yam production. What comes out from the certified seed yam planted on the field are referred to as ware yam, which can be used by consumers.
To ensure that we can produce and conduct our field activities all year round, we have solar-powered irrigation system which feed our plantings on the field for all year round production of clean seed yam.
This particular project extracts groundwater and then uses solar power, will increase to about 96%, which will all help and build the nation in terms of food security.
Our sister organizations are also utilizing this technique. So we are hopeful that with this technique, the seed yam system is going to be formalized. It's taking the next step to ensure that a vibrant seed yam system is established in Ghana and the sub-Saharan African region. Mpo Bayire, Papa, quality seed yam.